Hello students, welcome to my channel Concept Tech 2018. I am Sunanda Manke and this is the series on online electronics laboratory, and this is the part where we'll discuss the lab exercises on filters. Filters are basically circuits which are capable of passing signals with certain frequencies and reject the other frequencies, and this property of filters is called its selectivity. And the frequency response of the filter, basically it's a graph between the voltage gain and the frequency, and with the help of this graph we can differentiate between different filters. The filters are used to separate desired signals from undesired signals. They are used to block interfering signals. They are used for enhancing speech and video signals, and they are also used to vary the or to alter the signals in some other ways, like we can alter the phase or we can introduce delay for the given input frequency with the help of filters. The classification of filters, based on the components which are used in the filters, we have active and passive filters, and based on the frequency we have high pass, low pass, band stop and all pass filters. Passive filters use passive component, that is they use resistor, inductor and capacitor, whereas in active filters we use the active component like amplifiers. Operational amplifier is used with passive components, that is R and C. In the filter, the active devices are used for providing voltage gain. Op-amp provides the gain, and the RC circuit, which is the passive circuit, that is used to provide frequency selectivity. The active filters are normally used below 1 MHz and passive filters are used for high frequencies. Active filters are easy to tune compared to passive filters. This gives the ideal response for the four filters. We have low pass filters which passes low frequencies, attenuates high frequencies. High pass filter attenuates low frequencies, passes high frequencies. Band pass filter passes a specific band of frequencies, and band reject filter rejects or blocks a specific band of frequency. So we have pass band and stop band. The frequency in the pass band are passed through the capacitor, and frequency in the stop band are stopped, blocked or attenuated by the given filter. The assignment includes passive filters and active filters. Passive filters, as discussed, have R, L and C components, whereas in active filters we have operational amplifier with R and C components, resistance and capacitance. Coming to active filters, in active filters we have first order low pass high pass filter, second order low pass filter, Butterworth high pass filter and Chebyshev low pass filters. We'll do all these experiments. And here what do we mean by the order of the filter? Basically, order of the filter depends on the number of RC circuits which are connected in the filters, and the filter response improves as the order of the filters increases. That is, if we have one pair of R and C, then it is a first order filter. If we have two resistors and two capacitors, the filter order becomes 2. So as we go on increasing the number of RC circuits in the filter response improves. This assignment is on Chebyshev low pass filter. Butterworth's passband response is flat, but in some application more important is the faster roll off, and so we go for Chebyshev approximation where the roll off is very fast. This fast roll off results in ripples in the passband. The response is for 6th order filter with cutoff frequency of 1 kHz and A max of 2.5 dB. The number of ripples in the Chebyshev filter depends on the order of the filter. So if we have a 4th order filter, we'll get 2 ripples. N by 2 is the number of ripples. This shows a 20th order filter, so you can observe we'll get 10 ripples here, and the feature of Chebyshev filter is the ripples are having equal depths, right? So this approximation is also called equal ripple approximation. Here the attenuation is greater than the attenuation of the Butterworth filter. Let's do the experiment. Let's do the experiment with Chebyshev filter. You can see here we have Chebyshev low pass filter. This is 4th order filter and the lower one is the 2nd order filter. In 4th order filter we have 2 stages of 2nd order filters. So first of all we will observe the output from the first 2nd order, and then we will observe output from the 4th order filter. This is the output of 2nd order filter. It is a low pass filter, right? It will pass low frequencies and it will attenuate high frequencies. So we have a frequency of 500 Hz, 80 Hz, and the output amplitude is greater than input amplitude, as you can observe. Now go on increasing the frequency 120, 200 Hz, 400 Hz, 500 Hz, 600 Hz, 800, 1 point and 1.2 kilohertz, the amplitude becomes smaller. So, cutoff is around 1.2 kilohertz, as you can observe, right. 300, 500 hertz up to 500 hertz. I am changing the position of the output waveform. Lower one is the output waveform as before. The amplitude, input amplitude I am reducing to 1 volts, and output we are observing. So, 1.2 kilohertz output amplitude becomes smaller, right. And as we go to 0.8 kilohertz, output amplitude is bigger. So, it is a low pass filter. You increase the frequency, output becomes smaller. Now, we will see the output of fourth order filter here. Input is applied to the first second order filter and output is taken from the, and you can observe the amplitude at the output. The gain obtained by the fourth order filter is quite high compared to second order filter, and the response is same as before. This is 0.8 kilohertz, 100 hertz, 200 hertz, 300 hertz, 6, 7, 800 hertz, 900, 1K, 1.2K, and the response lowers, right. And 12K, 8, 7K, 6K, there is no response, right. So, the response reduces after 1.2 kilohertz. This is Chebyshev fourth order filter, which is a low pass filter. And there is one more thing, we have ripples in the pass band. So, see, the amplitude increases and then decreases. So, this is a ripple. If it is a fourth order filter, we will get two ripples in the pass band. So, let us observe it. It is a low pass filter, 12 kilohertz, no input, reducing it to 3, 2, 1, 1 kilohertz, and it increases. This is the ripple and it decreases again, right. So, we observed ripple in the Chebyshev filter. If we go little further, we can observe one more ripple here. It will slightly increase and see and it will decrease, right. Yeah. Let us do the experiment with the lower filter. It is a second order filter, same as the filter which is there in the first stage of fourth order filter. So, let us do the experiment for second order filter. Let us see Chebyshev second order filter, the input from function generator and output given to the CRO. CRO observes both input and output. Upper one is the input waveform, lower one is the output waveform. And let us see, reducing the frequency, low pass filter, it will pass low frequencies and it will attenuate high frequencies, right. Same setting, 1 volts for both the input and output, and you can observe the output for very low frequencies, right. The frequency is very low, so the output you can observe the tracing on the CRO. Now, we will increase the frequency and we will change the time setting. So, we get the stable waveform. Now, waveform is stable, and just observe, reducing the frequency increases the output, increasing the frequency reduces the output, right. Reducing the frequency increases the output, and we can observe one ripple here as it is a second order filter. It will increase and then it will decrease, right. It is not very clear on the CRO, but you can observe how this low pass filter works, passes low frequencies, attenuate high frequencies. We have observed the response of this experiment on the trainer kit, and kit has second order filter and a fourth order filter which is made up of two stages of second order filter, and we have observed the ripples in the passband. So, response is Chebyshev, and fourth order circuit response was better than the second order circuit here. The input was applied through function generator and output was observed on the CRO. I hope you have observed the ripples on the CRO during this experiment, and now you know the difference between the Chebyshev and Butterworth response. I hope you have enjoyed it. Thank you.